Hello, Spark fans, and welcome back to Advancing Spark, where we have a double feature of Databricks bonus news for you guys today. So we didn't manage to get a news update out in February. SQL Bits, massive data conference in the UK. I caught COVID, various things went on. Yeah, it's all fine now. But we didn't manage to do the roundup of all the different things that have gone into the Databricks platform throughout February 2022. And now it is the 1st of April 2022. So we're going to do March as well. So we're going to step through release notes for both sides. There's a whole load of new stuff that we can see. We've had public preview announcements for Unity Catalog, for Delta sharing. We've got a GA announcement for Featurestore. We've got a brand new Databricks Runtime in terms of 10.4 coming out, and loads of features around UI, usability, and stability, and performance, and all these different things. So we're going to do a big run through all of that good stuff. As always, if it is your first time around here, do not forget to like and subscribe. Say hello down in the comments. Let us know which of these many features are the ones that are the killer feature for you. Always good to hear. All right, let's go and have a look. As always, I've got the Azure Platform release notes. So don't forget, if you're in GCP, you're in AWS, there's a slightly different release notes page. And it's rare that there's that many differences, but there's one or two slight differences if we're talking about specific Azure things. So use the right documentation for your environment. I'm going to start right down the bottom. The first few in February, we actually managed to catch in the last newscast because I did the January one slightly late. Oh, terrible. So there's a few things we'll quickly whip through and then we'll start talking about the actual features. So 10.3, we did a review of that last time. MLflow can now look up live features from stores, which is super useful, super good if you're doing kind of feature stores on things other than straight batch records. You can now select which algorithms AutoML should be using if you want to kind of get rid of certain ones and kind of give it a kick in the right direction. A load of additional Metastore locations, giving additional places for that managed Hive Metastore to go and live. Catching up. Delta Live Tables now supports change data capture. So we just did a video about that. So change data capture is not the right word for it, it's merge. You can now merge records in a Delta Live Table change feed, which is really interesting. One of the biggest things missing in terms of Delta was you either had to completely overwrite the table each time, or you had to do append only. And that's going back to the old Parquet way of doing things. Now saying, yeah, it supports merge, it has this apply changes syntax, which just does a SQL merge under the hood. Loads of interesting stuff in there. Go and have a look at the video if you want more stuff on that. Got an updated Markdown parser, so if you've been used to doing headers in Markdown, you've got hash #, #, #, and then your title. You used to have to put a space, otherwise it didn't recognize those hash # symbols as a header. Now it'll work it out. Tiny change, useful to know. And then we're getting into new stuff. So Delta Live Tables used to be top-down, so it'd give you some boxes and follow down the line of dependencies and go down. Now you go from left to right. Not a major change, it's a slight switch in terms of how we're reading that. And there's more details when you click onto some of those little cards, the kind of the elements of your Delta Live Tables. Just the UI around that should generally got a bit nicer and a bit better. Okay, Databricks Repos now supports AWS code commit. Now I didn't know much about this, but looking into it, it seems a little bit like a AWS-backed Git repo. So if you're in AWS and you want to be able to use AWS code commit as the repo behind Databricks repos, you can now hook that up. Because previously it was fairly limited. You could talk to Azure DevOps and Git, Bitbucket, and I think that was it. So just adding in AWS code commit as another repo provider, you can hook into Databricks repos. Again, I don't know much more than that. Data science and engineering landing pages have been made slightly smarter, slightly kind of better. So again, we've seen the new style in the machine learning landing page and the Databricks SQL landing page, and it's just a little refresh of that. The first landing page, the graphics that you get when you first go into that data science and engineering workspace, aka the normal Databricks workspace, the default, it's just made it a little bit fancier, that's all. Runtime for 9.0 is ending, and again, that does seem crazy because it wasn't that long ago that we actually first saw the major release of the 9.x series of Databricks runtimes. But it's been 6 months. It has reached the end of its life. So unless you're on the LTS version, which I can't remember if that's 9.3 or 9.4, you do need to be making sure you're moving up those runtime versions. Okay. The user interface changes inside DLT, Delta Live Tables. So there's a few things. So whenever we had settings changes, essentially if you've used the UI at the start to put a load of things in, you go, right, create my Delta Live Tables pipeline. And then if you're like, oh, I need to change the cluster config, or I need to change some of those details, you'd edit it and it'd give you just a big old bit of JSON, and you have to manually edit that JSON. So they've made it better in terms of actually sort of going in and editing that and be able to switch over to the UI mode to actually get onto a load of features, which just makes it easier actually sort of in terms of structuring it and validating it, making sure you're not butchering that JSON config file and it just won't work. There's also a little bit of better support in terms of what's happening when it's running. And I think we saw that in the CDC video. Previously, if your cluster hadn't turned on, you wouldn't get the graph view and you'd just get a nothing until the point at which the job cluster was turned on. You pass that graph and then show it to you. Now you at least get this is the state that we're in. We're currently setting the cluster up. We've set it up, we're initializing Spark. We've done that, we're now building out your DLT graph. You get a better state of where you are currently at. So general improvements in terms of the user interface when actually running things, editing things, and playing around with the DLT pipelines themselves. All good stuff. Another interesting one, temporary tables in Delta Live Tables. So normal Delta Live Tables, or previously kind of up to until now in Delta Live Tables, we've had a view or we've had a table. So a view is literally just a high view, right? You can put some logic in there, we can stitch tables together, apply some business transformations, and it doesn't land there anywhere, it doesn't materialize that data, it doesn't write it down to the lake. That's just a logical construct. Or a table, which case it writes the whole thing down and it exposes it and it adds it to the Hive database. Users then see that as a registered Hive table pointing at that Delta table. They've now implemented this temporary property of a table. So if you had a view that was just so complicated and stitching so many things down, and then you were joining that to other views, and you're like, if we're doing that normally, we'd go, okay, look, I just have to write that down as a full table so I can then use it in a join without having to calculate everything on the fly. There comes a point when you have to materialize just for complexity. And that's essentially what this is doing. So we can apply something temporary, it'll write it down, it'll create a Delta table for it, but it won't register it with Hive. Do the special things in there. So super useful if you are trying to do DLT for things that are now fairly gnarly, fairly complex. This is a super useful little switch that we can add in there just to kind of replicate some of the patterns and processes we have when doing full engineering. All right, other bits. The experiments page is GA. So that's when we have ML flow and we're logging things and we're tracking all various experiments. That's now gone generally available. I didn't know it wasn't generally available. I assumed it was already, but it is now GA. There we go, that's always good. And drop data sets in AutoML. So AutoML, you give it a data set. You go, here you go and use that. Come up with the best way to predict X figure, whatever it happens to be. And if we wanted it to ignore certain columns, we'd have to shape the data set specifically. We'd have to go, okay, let's make a new data set that doesn't have that data. We don't want AutoML to use that. Maybe there's an ID that completely overfits. And then AutoML will run and go, well, obviously I'm just going to use the thing that predicts it exactly because it's tied to it. So if we want to train the model and want it to actually just use a subset of those columns, we had to give it a special data set to use. But that means that we couldn't actually point it to an existing data set that has a load of extra information and target down to just a bit. We'd have to always make a separate data set. Now we can drop columns. So essentially we can just say, hey, AutoML, take this big wide table of all my stuff, but don't look at those bits and pieces and then do your stuff without having to create and curate these separate data sets. So super useful for sharing data, for working in an enterprise state. We got loads of common data model things that you're sharing. Okay, job running. So if you have a job cluster, so you've got a job and you said, I don't want to use an existing interactive cluster. I want to use a job cluster, essentially a single serving cluster that gets spun up just to do that particular job. You couldn't really see much about where that came from in the clusters UI. You can go into clusters UI, you can say what job clusters, and you'll see a list of them. But you don't really know who did it, why, you kind of which job it came from, but that's about it. So again, now you get the job runners. So if someone kicked it off, you'll see the person that kicked that job off, not the person who owned the job. So it's fairly misleading. Previously, if I went in, kicked off a thing, I didn't create the job. Inside job clusters, you'd see the other person's name who actually created the job initially. Not anymore. You now get job runners, which is probably more accurate, more useful to work with. Okay, MLflow compare runs. So if you did multiple different experiments in our nice new GA experiment tracking, we can now go, well, actually, how did that run against that one? And get differences in terms of the accuracy of the rock curve, the various different stats that came out from those different runs. It's now slightly better for us to be able to compare things and get a little bit more information about it. So if you are using that, definitely go and have another look. It has been refreshed in February. Again, we can now do it between different experiments. So they've made it better inside a given experiment, comparing run 1, run 2, and run 3, etc. But actually, you can take entirely different experiments, the different completely sets of tracking you're doing, and say, well, I'll compare that one to that one. Essentially just making it a bit more flexible. Wouldn't always make sense to do, as long as you're trying to predict the same thing, though. It can be quite good and allows you to then break up experiments, not just have massive experiments that have loads of different approaches and experiments and people all in the same one. You've got a bit more control if you can cross-compare between the two. Okay, jobs have been made a little bit fancier. And there's two main parts to this, actually. I think there's another one just up here. Yeah, so when you have a job that is constantly running or kind of constantly restarting, it's really good to have an idea of going, well, actually, well, what number is it up to? And can we recognize this ID? So now when we're using the jobs API and we're kicking off a job, we'll get a job we'll get back a job ID that allows us to uniquely identify that particular running instance of that job. And we also get this kind of number in job field. So again, useful if we are like iterating over several retries, if we're doing kind of several batches of runs that we're kicking off. There's a few more bits and pieces to improve how we're working with that. And that links into this one, where we can give it a unique identifier for the instance of job execution that we're asking for. So if I call the job API and I would run job number 1, by the way, I'm going to give you this ID of A, and then I didn't get a response back. There was a blip in the network and I didn't get the success point back. And so my system tries again and goes, can you run job 1, please? Previously, I wouldn't have a way to say, can you run job 1 unless it's already running and I've already asked for it. So if I call it again and I've got a retry logic and I go, can you run job 1? I'm still trying to do instance A. You go, oh no, A is already running. You've already asked for that in terms of that instance. That allows you to uniquely identify a particular request for a job to be run so that you don't duplicate runs of things. If you're building that into it, that allows you to make sure things run once and only once. You can pass that in. That is the idempotency token. So super useful. If you're building out a lot of automation using the jobs API, definitely take a look at that and definitely look at building that in, just so you can have quite fancy retry logic. You can be a little bit more, it doesn't matter if we request it several times because we're giving it that ID, so it's never going to run multiple times, and we can ensure we get the right, we can ensure it always runs. Okay, back to Delta Live tables. So the history of DLT is getting a little bit better. So you can go and browse the kind of the changes that you've made or changes to the updates. You can go into the update history of the DLT pipeline and go and actually sort of see all the things that have happened in there a little bit better. Again, if we just a sea of all these different events. And you can schedule it slightly nicer. So now there's just a nice button saying, schedule this on the DLT pipeline itself. You used to have to go into jobs, create a new job, and then pick your Delta Live table pipeline from a list. Now we can just, from inside the Delta Live table itself, go schedule this, please, and that'll create a job for us with the relevant schedule and management and all that kind of stuff. All gets nice and easy. Oh, okay, I realize we're going at pace. We've got a lot to go through. That was February. There are loads of changes in there. So the improvement around jobs is all good. Lots of Delta Live table changes, especially the ability to merge is a huge, huge, huge piece. Lots of things going on. Okay, next we had March. Gotta go right down to the bottom so we can do it chronologically. There's a few different things going on. So there is a new Databricks Runtime. So we've got 10.4, has a load of stuff in there, and we'll come back to that. We've got another tab. We'll get onto 10.4. We'll look at time. So cluster policy changes. So diagnostic logging is when we're kicking things out to things like log analytics. And we're saying, well, someone's added a new cluster. Someone's deleted the cluster. They've added a notebook. Any kind of material change you make within the workspace, we can have spat out into our diagnostic loggings, funneled through to log analytics if that's how you built it. But if you change the cluster policies, that didn't get spat out. So someone could actually just actively change the cluster policy and you wouldn't see it in your logging and your diagnostics. So it's a simple change. You can now actually have that included. So if you're changing user permissions or you're creating, updating, or deleting a cluster policy, that can be included in your diagnostic logging that you're kicking out into log analytics. So it's super useful. Just be aware it's there. Okay. Databricks repos has gotten a little bit better. So we saw in the February change, we had that new repo, that AWS Connect code commit thing added in. And now we've got kind of a few more actual browsing features inside the Databricks repo. So we can do a search and replace. So similar to if we had VS Code open and I had a load of notebooks and I was like, oh, I've just refactored, I've changed a variable, I can do find and replace and change it. Not the best way to refactor, honestly, but it is what it is. We can now do things like search and things. We've got this new file and edit menus. You can search for things amongst all of your repo. You can do a replace, you can replace all. That's quite nice. And the other bit is this limit. So previously you had a limit of you could only have 2,000 files in a repo. Now, in the grand scheme of things, that's a lot of files to have in a repo. But then if you have a look at some other types of project, if you had more than just Databricks inside a given repository and you wanted to have just folders inside your repo, maybe there's a collection of things like your lake definition and some data factories as a scheduler. There's a few bits and pieces that you've got that are working in collaboration and you want to keep that as a single repo because you deploy it together and they are tied together in terms of release cadence. You might have a load of other arbitrary files. Certainly if you have things like databases, database projects, that creates a load of arbitrary build files that are still in the repo. And you probably want to git ignore, but still. So there was a point when people were reaching that 2,000 limit. So whilst it might not have been 2,000 actual notebooks, with all the other stuff in that repo, if it's going over that limit, then Databricks repos are saying no. And that limit's now been upped to 5,000. That should be enough for most, unless you are absolutely in the monolithic repo line of thinking and you've got tons of other stuff in there, but that's probably not what you should be doing. Okay, better error handling. So if you're using a lot of Python functions, it was basically there was a few things that would break, which is not good. So essentially if you had a load of things in your properties and it was spitting out essentially, you could write bad settings in your Delta live table and it would break without telling you why it's broken, which is no good. And they've improved it. That will now error handle it properly, and it will actually tell you off and actually give you an error message, which is nice if you've got something wrong in your DLT pipeline setup. Another DLT change, we've now got a preview channel. So if you want to be on the latest and greatest of the Delta live tables, you want to see these new features come through as they're released, you can be on that preview channel. If you don't, if you want it to be stable and you want to be only things that are thoroughly tested and have gone GA and are fully working, not that any of it's GA, but still, if you want that side of things, then that has to be actually managed and controlled. And it is a good sign that we're getting closer to that productionized version of Delta live tables. So you can now opt in and say, I would like to see the preview features, or opt out if you want it to be the latest stable build, and you've got that choice as part of your channel settings inside the DLT itself. Another one we've got is access control within Delta live tables, which again is another great story for productionization, getting it to a point when it's mature and has security and has granularity. So who can manage it? Who can run it? Kind of similar to how we've got with notebooks. You can say, you can edit that notebook, you can read the notebook, you can run the notebook as different control plane permissions that we can set. Now we can do similar things on Delta live tables. So we have set a permissions model that we can apply into it. Okay, you can now rotate customer managed keys. So if you are using your own customer managed keys, you don't want Databricks to manage the keys for you. You can now actually update the key, which is useful. Because previously you'd set your key and then that'll be it. And you're like, oh, is that secure if I can't change the key once I've set it? Because surely they're rotating the keys that they use if they're doing managed keys. Now you can update it. So if you're using if you're using your own encryption keys to manage Databricks and your lake data and your config data elsewhere and other key vaults, whatever it happens to be, you can now have that central process and push updates and rotate those keys on a regular cadence, and that will now work, and you can push it into Databricks to do that. Okay, a couple of the big announcements. Whoa. Delta sharing is now in public preview. So Delta sharing, we've been hearing Databricks talk about for a long old time now. Now that is when we can say, essentially we have two objects. We have a sharing server and we have a share, some kind of data you want to share. So if I've got a Delta table, I've got a Delta table sitting around and I want to call an API and get hold of that data. Now what the Delta sharing server will do is basically just act as a separate serving layer for that. I can call into the API of that sharing server and say, hey, I want this bit of data, I want these filters on it, essentially writing a bit of a query on that. That will then, the sharing server will then go and talk to the data, figure out what I need, look at the Delta transaction log, and then send back keys, or single serving keys, to get that client to go and talk to the data directly, just pull back the files it needs. Essentially, acting as an abstraction layer so people don't have to be querying the Delta tables directly. So it allows us to share data sets amongst organizations across clouds without doing a whole load of really, really horrible, gnarly data movement-y type things. It allows us to better share things out. So we're talking about things like data meshes. We're talking about federated lakes. We're talking about kind of actually having wider things that has to have a security mission model behind it. It's really kind of interesting use case of sitting in the middle of that. Now, it's been in private preview. There is an open sourced version of it where you can just download it from Git and build your own sharing server and actually then kind of have your own clients and try it out. Whereas actually what we're going to see is now built into Unity Catalog, a Delta sharing server. So we're going to actually sort of be able to go and have a play and actually sort of use Unity Catalog to serve data out on our behalf. That's now in public preview. It's a gated private preview, public preview. So you still need to say, hey, Databricks, can I get access to it? And then they'll kind of add you to your list, and then you'll eventually get access in your workspace. It will be enabled for you. But really interesting that that's now public preview. Other interesting things is that we can talk about it. So as soon as I get my hands on it, we can do some videos and we can have a look at Delta sharing and how that all fits together. The other side of the fence, Unity Catalog is now in public preview. Also, again, a gated public preview. So it's a public preview where you have to go and ask Databricks, ask your local account exec and go, hey, really interested. Can we have a look? We have this use case. This is why we need access to it. And then you're going to go and start having a play with the features. Now, you've probably heard of Unity Catalog. Databricks have been talking about it now, again, for best part of a year. If you've not heard of it, it is essentially a data governance tool. It's a data catalog. It's a data security and management feature built into Databricks itself. So it's a little bit like the Hive Metastore. So if we're in Databricks and we go to data and we get a list of our databases and we get a list of the tables underneath, except it can work across lots of different workspaces. So rather than the current managed Metastore, which is just we see the data that's been registered in Hive in each of our workspaces, we only see its own data. Now we can say, what if all my data has been registered across all of my different Databricks workspaces that I might have? We can have a big centrally managed security model of who's allowed to see which bit of data. And they talked about things like row level security. They talked about, kind of sending out cataloging permissions and sensitivity labels. Well, that's confidential. And then you're allowed to see confidential data without having to say you're allowed to see that piece of confidential data. There's an interesting security model in there that helps us do that. Plus, they showed lots of things around, might not be in this preview yet, but they've shown things like lineage tracking, extended metadata and descriptive metadata, acting like a data catalog, so people can go and use it as a data dictionary and go and figure out good documented data stores. Essentially, another step in the maturity of the lakehouse model of actually having a properly documented data model. So loads and loads and loads and loads of stuff inside Unity Catalog. Again, as soon as I've got access, we'll be doing a video, we'll be pulling it apart and actually sort of having a look at how we can use it. I don't have access yet. Oh, then the runtime 10.4 that was in beta at the very start of this section is now GA. The biggest thing we need to note is that is now LTS. That is a long-term support. So that normally means it's around 12 months, 18 months, sorry, of lifetime. So like we've seen that we had that 9.0 is now no longer in support because it's reached its kind of that 6-month drop off. This one's going to be around for a lot longer. So if you're looking at the latest stable long-term build and you don't want to be upgrading your runtime every few months, 10.4 is the latest that's good for that, and that's now GA. A load of features, and we'll talk about that in a moment. Okay, now I don't know too much about this. So the RStudio Workbench depends on cookies when you use a license file. They would not allow listed for proxying. So essentially, it was not really working. That's now been fixed. So if you have been using RStudio and you're coming across errors and just basically not being able to connect, that should now actually work. Go and have a look. And again, that was rolled out. That should have finishing rolling out across all the workspaces now. Okay, you can now share an experiment. Essentially, it's just a quick change. I've used to have permissions, and you could set permissions on a particular experiment. Now it's just been renamed to share, but it does also give you a shareable link. So you can send someone a link to an experiment in your ML flow tracking, and that will go and actually then publish it, and they can go directly to it. Other big one, Featurestore is generally available. So we've been doing a few videos around Featurestore recently. So that is our ability to, when we're doing the feature engineering part of the machine learning process, so we're taking a data set, we're augmenting it, and we're doing some cleaning up of values, we're doing some encoding of things, we're doing some looking up into other reference data, and we're potentially manipulating, massaging the data into the right state so it's ready to pass into a given model training. And it produces a load of delta tables, which are essentially used to just manage lookup tables. So that really interesting thing that's kind of a massive performance enhancement for loads of data science teams, that is now generally available. It has been in preview previously. So again, if you're looking at Featurestore and going, yeah, okay, I quite like the idea, but it's in preview, I don't want to use it. No longer in preview, you can go nuts and actually try and use it in anger in production workloads. Okay, finally, we've now got this Databricks enhanced autoscaling. So if you're using autoscaling in Delta live tables, we should actually see some interesting changes for your streaming mode and your batch modes, whether you're using it continuous or not. We should just see the cluster being used better. So you can get away with having a smaller cluster, or essentially it will auto-scale down and be using a smaller cluster wherever it can. So we should be seeing slightly cheaper Delta live table processes. Now I'm interested because it's one of those things, because Delta live tables is still in preview, how much have we actually seen of people doing it in anger and having production workloads, having production data volumes, and then the cost management that we're seeing from it. So I'd be interested if people are using it and trying to use real world data volumes. What are you seeing for costs? It is on job clusters, so it should be fairly cheap. And if this is making it even cheaper, it's great. So yeah, definitely be interesting to see if anyone's seen material improvements, if you've seen things just go a bit faster, or if you've seen things not really change, but actually if you go and have a look at it, it's going to be cheaper because it's been just automatically using less compute because it's been auto-scaling better. Definitely a really interesting thing to go and have a look at and investigate. And that brings us up to date. That is everything that is in there between February and March 2022 in terms of all the features. Now, obviously, there's the two big ones in there in terms of Delta sharing and Unity Catalog now available for public preview. And I know it's frustrating. I'm frustrated that they are gated. You can't just go and have a look in your workspace and have a play now. But I do promise I'll try and get a video out as soon as we can. Now, how are we doing for time? Oh, it's going to be a long video. Let's go and have a look at Databricks Runtime 10.4 LTS, long-term support. Again, this is now GA. This is generally available. You can use this in anger. Got loads of features that we can have a quick whip through. Number one, controversial. You can now convert a Iceberg table to a Delta table. Essentially, it's kind of stripping out some of the Iceberg metadata and using it to create the Delta transaction log and the file manifest that lives inside there. So really interesting and actually great, right? We should be able to, if Iceberg and Hudi and Delta and all these kind of like latest generation leg file formats, if they're working in similar ways and they're collecting similar metadata, it's good that we're not locked in, that we can move around, that we can switch it out. Obviously note that this is a one-way Iceberg to Delta, not a vice versa, but it's still a very useful tool, and I want to see it going all the ways. I want you to be able to go and just take your entire thing and go, right, switch the entire thing over to Hudi. Actually, no, let's switch everything back to Delta. And the more we can do that, the less scared people are to adopt things because you're not locking yourself into a particular format. So really good. Definitely like to see it. It'd be interesting to see how many people are going to switch over to using Delta because they were previously felt locked in and they didn't want to have to manually lose all the richness and metadata inside their Iceberg files. Okay, so AutoCompaction rollbacks are now enabled by default. So essentially, if it tried to write into, if it tried to do an AutoCompaction is one of the auto-optimized elements. So you got optimized writing AutoCompaction, and that's essentially, once it's finished writing, it kicks off a mini optimized job. So it goes back, looks at the folder, and then says, I'm going to go and change a load of stuff. Now, if you were doing that and it would try to do an AutoCompaction and then someone else was writing to it, the things writing to it would quit because you're in the middle of doing an AutoCompaction. So essentially, it's all about kind of concurrent writes into it and protecting it if there was compaction. So it's like, right, okay, I'm going to go run and optimize, but then kill things, and that's not good. So essentially, that's now gone in. So that'll now fix it. So even if there are concurrent AutoCompaction, it's still cleaning up the last writes. It'll still do the new writes. So your writes are protected, and you can have some transactional consistency on top of there. That's good. Wasn't really a thing I'd looked into. Interesting. Low shuffle merge is now enabled by default. So merges previously have a ton of shuffles. So if you've got a load of files that are all nicely organized and they're optimized, and your file kind of skipping is all like perfectly preserved, and then you'd go and do a merge and it was updating a load of data. Essentially, it would pull all the data, shuffle it around, figure out all the changes, and then just write it out again. And that could have just a quite disastrous amount of shuffling. Low shuffle is essentially a change to the query execution plan. There's a change to how it's actually going to go and tackle and work with that data to try and reduce the amount of shuffles. So if there's data where we know things aren't changing that much, don't shuffle it. Just leave that chunk of data alone. And there's some processes around that just to make things a lot faster because it's not doing as much data movement. And shuffle is one of the things that slows down Spark jobs the most. So low shuffle, really, really good. And essentially kind of isolates going, right, well, these things are going to be updated. That's going to be an insert. We don't need to worry about shuffling the insert into the rest thing. We can just get that data down. So it changes the number of files that you'll end up with written out, but it means the actual execution plan is much, much faster. That is now enabled by default. So you might see your merge statements. If you're using merge heavily, you might see the performance of that quite drastically change with this going in from 10.4 being enabled by default. Previously, you had to turn it on. That's a Spark configuration you'd have to enable. And you can turn it off. If you don't want that to happen, you can go into the settings and turn it off. It's not right for every workload, but it's pretty good for most workloads. Okay, linked to that. So insert order tags are now preserved for updates and deletes. Oh, that sounds fancy. But essentially, if we had done all that work and we'd had Z ordering and we'd had kind of, we'd had all our nicely optimized min-max statistics on each of our file to try and improve file skipping, to try and reduce the amount of data we read each time someone tries to query the table, and then we did an update or a merge, or we did a delete, it essentially picked the data up and it wouldn't respect that original order. So essentially, every time you update a table, you'd have to optimize the files that you'd written. And we've kind of gotten used to having to do that. Now it's kind of pulling it up and going, well, oh, that's already in a good order. I'm just going to maintain that order and write out the data in the same order it was, rather than just ignoring it and shuffling it. Order doesn't matter. I'm a Spark cluster. So you should find behavior, the actual files that are produced at the end of an update, delete statement, and all that kind of stuff, is still as optimized as it used to be. Now, as it says, it's a best effort approach. So it's not going to be absolutely perfect. If you want to be absolutely, sparkly clean and all this stuff, then maybe, yes, you need to optimize each time you've done this. But actually, it'll mean that if you're doing some regular stuff, if you're doing regular updates, you don't have to be very, very paranoid about doing an optimize every single time. Okay, the change over the connector to the Hive Metastore. So that's now Hikari CP. And again, kind of, I don't know if that's going to be, if that's had a massive, massive change on things. Essentially, it's a little bit faster because it maintains fewer connections, which is good. So if you're having a hugely concurrent number of users that are actually going and using your Databricks workspace, that might have been having issues. I've not seen any major things there. But essentially, kind of, if you're having any issues with the Hive Metastore, we should have seen some changes. And we know there's a load of work going on there because we've seen all these additional Metastore locations cropping in the past few months worth of release notes. There's a massive amount of work to actually just essentially improve the backbone architecture and infrastructure of all the metadata management stuff, probably with things like Unity Catalog coming in, which obviously exposes so much more information and works better at abstracting that out. And it's just a fix to make sure that's going to be a little bit more stable, a little bit more kind of predictable, a little bit more performant. Okay, Azure Synapse connector now enables a maximum number of allowed reject rows to be set. Now, this is specifically just around dedicated SQL pools. So maybe serverless. When you create an external table, so essentially when you're using the Polybase engine, then that can reject rows. So essentially we can say, well, this is the schema that I'm expecting. Go and read that data. And if there's any rows that we're inserting that don't match that schema, reject that row and write it back down to the disk in another reject rows location. Now, so that's something we've been able to do in the SQL data warehouse. Now, Synapse dedicated SQL pools. And now it's simply exposed in that connector. So if you're in Databricks and you're using the Azure Synapse Analytics connector, it is assuming you are writing it to a dedicated SQL pools table. It's going to create a Polybase external table for you. It's going to seat that into a staging table, kind of a new table, wherever you do it. So that whole thing is built to essentially create those external table objects, the data source, the file format, all the things that you normally need to build manually, copy your data in, and then clean those objects up. And this new feature is now saying we can take advantage of the reject rows. So if you want some rows to be rejected as part of that movement, then that can be built in. I don't know why you would, but you can now. Asynchronous state checkpointing is now GA. So we heard about this as a preview thing of essentially previously when we're streaming inside Spark, each micro batch, it finishes writing the data down and then it goes and writes to the checkpoint. And then it starts the next job. So that kind of writing to the checkpoint is just part of that path. It won't start the next job until it's finished writing to the checkpoint. And now this change is saying, well, actually, we can start the next job while we're still writing to the checkpoint. There's no dependency on that. So actually now it does asynchronous state checkpointing, aka it'll kick off the jobs to be writing to the state at the same time it's starting the next micro batch. And that's no longer a thing, which will just generally reduce the latency in your micro batches. If you're trying to get streaming to go faster and faster and faster and faster and faster, this is a big step in terms of helping just to remove that little gap in between each micro batch starting. Okay, SQL Functions. So we saw a few months ago they released the ability to have SQL Functions as a user-defined function. It's just going to be a lot more performant of doing things like the pandas functions in Python, or kind of writing your own R functions, which always have performance and scalability issues. You now do it in SQL, it's going to run natively on the Spark engine, it's going to be a lot better for scaling. And they've added the ability where you can provide defaults. So if someone calls that SQL function and they don't pass one of the parameters in, it'll have a default value it uses rather than having to break and having to force people to use that every single time. Super useful. We've got two new Spark SQL functions. We've got try multiply and try subtract. So essentially, it's wrapping it with a null if it errors. So if it manages to do a number multiplied by a number, if there was an overflow, if there was any issue with doing that, it'll just return a null. Nice and easy. So a lot of this stuff helps when we're in full ANSI mode. So normal Spark, if you tried to multiply two numbers together and you weren't using the ANSI mode SQL, then it would just go, yeah, fine, and give you a null. If we're turning ANSI mode on, then that states that has to fail. That has to go, no, that doesn't work. You can't multiply this by a null or whatever the thing happens to be. Or you can't multiply two things that aren't numbers. Then that would give you an actual error. So now this is kind of like our try pass things of try and multiply it. Multiply this by this. If it fails, return a null, essentially replicating the behavior we had previously, but allowing you to do it inside full SQL ANSI mode. Working directory for high concurrency clusters has changed. So if you've got loads of users on there, rather than all sharing the same Databricks driver folder and then perhaps getting in each other's way if they were doing lots of local writes, essentially now each one, the kind of your home folder when you're running any kind of high level Python, is your user's home directory, not the Databricks driver directory. Yeah, fair enough. And identity columns are now GA. So this is the one that we saw kind of released in 10.3, but not publicly exposed. Now we've got the ability, so we can say create table identity columns. essentially allowing us to do things like surrogate keys. So it's going to be interesting to have a look at this. I'm going to need to do a video of this very, very soon. So if we are defining a delta table, we can say this table has a unique identity. We can give it an increment, and we can give it a starting seed. And that's very similar to the way that SQL Server identities work. Now, if we're actually relying on the fact that this is going to be densely stacked, I guess, SD sequential, it's going to be interesting. But because we've got that increment in there, makes it quite likely that we're going to. Previously, so we see in a lot of parallel systems, similar to how monotonically increasing ID works, if we say come up with a new ID, it leaves big 8 billion gaps between numbers. So on one particular worker, the RDD block that we had there, it would go 1, 2, 3, 4, 5. On the next RDD partition on a different worker, it'd go 8 billion and 1, 8 billion and 2, 8 billion and 3. And you have these big gaps where it leaves it empty because it does not want overlap of values. We want to have it so we're not going to have duplicates, and we want it to be fast. We don't have to go and check for each individual insert what number we're into, and so leaving big gaps is the fastest way to do it. So really interesting to go and dig into this and see how fast is this going to be. Is this having to manage a sequence across things? How well does that perform when we're trying to insert a lot of data at once that is scaled across quite a few different workers? So super interesting, really, really useful. A massive thing to bring SQL people who are used to building a SQL warehouse onto this platform, because identity is how people do things like surrogate keys in traditional warehousing. They just need to have a look and figure out how well it works. Cool. And that is it. That is our list of stuff inside 10.4, the new LTS Databricks Runtime. It is GA, so all that stuff in there you can go and have a play with now. You can go and have a look at how that's all working. And there's a few bits in there that I want to take a look at. So there'll be some follow-up videos where we'll go and have a bit of a dig. Oh, how are we doing? Oh, that's a long video. Oh, man. But it is 2 months. There's loads of stuff in there. I do recommend you run through the release notes yourself. As always, don't take my opinion for everything. Go and have a look through the release notes. And then, yeah, give it a go. It'll be in your Databricks workspace now. Should see all those changes in there. And you can go and have a play with that latest Databricks Runtime. Oh, all right. Well, I'll see you for the next videos. Hopefully when we'll dig into some of these changes. Until then, look after yourselves. Don't forget to like and subscribe. Cheers.